The Psych chart is a way to quantify the different states of air. And we've got a bunch of different lines here, a bunch of different metrics we can use to quantify the amount of water vapor and the heat within it, the density of the air and the heat, the overall enthalpy like we talked about, the relative humidity, which is what we feel when we think of humidity. So this is a great one-stop shop to kind of understand the state of air in its totality. Now looking at the different axes. At the bottom, we have our dry bulb temperature. So going from left to right, we're going from cold to hot. Like just like you see it when you check the weather, you're looking at the dry bulb temperature, not the wet bulb. When you're looking at, okay, how hot is it gonna be today? That is left to right, straight line, horizontal on the Psych chart. And then on the y-axis here, this is the humidity ratio. So going from bottom to top, straight up, this is the ratio of water vapor to air. Humidity ratio is not the same thing as relative humidity. When we use the word humidity in just everyday plain speak, we're talking about relative humidity, not the humidity ratio. And when you check the weather, you're looking at temperature, dry bulb, and when you're looking at humidity, you're looking at humidity ratio, which is expressed as these 10%, 20%, 30% here. This is relative because we can tolerate higher humidity ratios, right, if it's warmer out. So it's 100 degrees, and let's say the humidity ratio is at like 0.014 right here at 100 degrees. The relative humidity is about 35%, right? 35% relative humidity is not bad. It's actually kind of going towards the dry side. Then as the dry bulb starts to drop, if it gets cooler, but the humidity ratio stays the same, now we could get to like 70 degrees, but the relative humidity is now at 90%. I personally would much rather be in 100 degree, 35% humidity weather. 70 degrees at 90% relative humidity is rough. But it's the same ratio of water vapor to dry air. It's the same humidity ratio. It's just now relative to the density of the air, 90% relative humidity. Not very fun. So that's kind of how relative humidity relates to both dry bulb and your humidity ratio. Last one is you'll notice that this chart is not a rectangle. It's got this limit right here. This limit right here is the dew point of your air. So we talked about how when you start cooling air, you get to the point where it becomes too dense to hold water vapor. When it gets to that point, that is the dew point, and that's what this edge of the chart is right here, where you no longer have any data. So once I hit about 67 degrees dry bulb, now the air is too dense to hold that same amount of water vapor, and it starts condensing.